All right, so this video is going to go over pages 8 through 10 in your vectors packet. So we're going to start with a trigonometry review. Okay, so a couple of things we're going to have down is we're going to have a squared plus b squared equals c squared. So that's our Pythagorean theorem. And then we're going to have sine of our angle equals opposite over hypotenuse. Cosine of your angle is adjacent over hypotenuse. And tangent of your angle equals opposite over adjacent. So I'm going to be referring to those. I just don't want to write those down multiple times. So have these written down somewhere so that you can look at it, because I don't want to keep writing it and just kind of waste time. So number one, a newspaper delivery boy has been told to stay on the sidewalk when delivering the paper to a customer's front door. But according to the diagram, if he cuts diagonally across the grass, how much distance can he save? So basically what I want to know is what would this distance be right here? So that would be my x. Now, I've got two sides of a right triangle. Okay, so if I want to find the hypotenuse, we're just going to use Pythagorean theorem. So x equals, and we're just skipping a step here because we know c squared, we got to square root both sides. So we're going to square root whatever a squared plus b squared is. So 15 squared plus 12 squared, and we're going to square root the whole thing. And you get a hypotenuse of 19.21 meters. Okay. Now, if you want to know how much distance you could save, okay, you could figure this out, because if I walked 15 this way and then 12 that way, that would be 27 meters. Okay, so that would save me roughly about 8 meters in distance. But I care more about, can you find the hypotenuse? Number two, find the missing angle. Okay, so we're looking for the angle right here. So you got to make sure you can label your triangle of what you have. 200 would be your hypotenuse. 75 would be your opposite, because again, it's opposite of your angle. So I would look at my three trig functions. Which one has opposite and hypotenuse in the same one? That would be your sine of your angle equals opposite over hypotenuse. So sine of my angle, I don't know my angle. I'm going to leave it like that. Opposite would be 75. Hypotenuse would be 200. Now I've got to bring that sine over. I can't have it on the angle, so I'm going to bring it over here. And when I do that, it becomes inverse sine of 75 divided by 200. Okay, so again, just press second sine in your calculator, and that'll give you inverse sine. Make sure you're in degree mode, and you'll get an angle of 22.02 degrees. And there's your answer right there. Number three, find the x, the horizontal, so right here, and then y, find the vertical of the components of the triangle. So we got to look at, what do we have? We have in the angle, and we have our hypotenuse. Okay, so we're looking for y. Okay, that means that's our opposite. And we're looking for x, that's our adjacent. So let's do one at a time. So you can't do both of them in the same one. We're going to have to do two trig functions here. So I want to see which trig function has opposite and hypotenuse to find y. Well, that's going to be sine. So sine of your angle, which is 35, equals opposite. We don't know, so we're going to leave it as y over your hypotenuse, which is 70. Okay, so y equals, if you just multiply both sides by 70, so in your calculator, you're going to type in 70 times sine of 35, and you'll get a value of 40.15. Now, we're going to do the same thing for adjacent, but we're not going to use sine this time. We need to figure out which one has adjacent and hypotenuse. That is going to be cosine. So cosine of 35 equals x over 70. So same thing, we're just using a different trig function. So whatever 70 times cosine of 35 is, that's going to be 57.34. Okay. So let's move on to this is actually the homework part now. So we're going to do these. It's just a lot of practice just finding the hypotenuse and the angle. Okay, a dog walks 300 meters east and then 400 meters north. Okay, so I'm going to draw my directions. Okay, so we're going east. So I'm going to switch colors real quick. So I'm going to go 300 meters east. And then from there, I'm going to go 450 meters north. And then tie back to the center. Okay, so my angle would be right here. And then our hypotenuse, we don't know. I'm going to say it's x. Okay, when it says what is the displacement, Okay, that means you need to give me the magnitude and the angle. Okay, so the magnitude just means find the hypotenuse. Angle means we just got to find the angle that they actually went. Okay, so in order to find the hypotenuse, we're going to take the square root of a squared plus b squared, so that is 300 squared plus 450 squared, and you get a value of 540.83 meters. Now that's your magnitude. That is basically part of your answer. Okay, and if you feel like you need to pause this video at any time and you want to work a problem out and then see if it works and stuff, by all means do that. I'm trying to just get through this video fairly quickly. So just pause and rewind when you need to. So now we're going to find our angle. Okay, so if I was labeling my triangle, I have my opposite and I have my adjacent. So I would see which one has opposite and adjacent. Okay, that would be tangent. Okay, so tangent of your angle equals opposite, which is 450, over your adjacent, which is 300. Okay, so I've got to bring that tangent over. So that's basically saying inverse tangent, so tangent with a -1 of 450 divided by 300. Okay, so type that in your calculator, make sure you're in degree mode, and you should get 56.31 degrees. I'm touching the east line. Okay, that means that's got to be my last letter, so this is going to be north of east. Now, if you did the other way, say you went north first and then east, okay, your angle would be 33.69 degrees east of north. Okay, so I would accept either one. Number 2, a plane flying 200 kilometers an hour west with a crosswind out of the south. Okay, what that means is we're not going to try to give you this on a quiz or a test. I've seen some confusion on that. If the wind is coming out of the south, that means it's blowing north. Okay, so I have a 200 kilometer. So let's go ahead and draw my directions. Got north, west. Okay, that's pretty much all we need. So what we're going to do is I'm going to go 200 west. Kilometers per hour is just your unit. That just means velocity, so you don't need to do anything different. Okay, so don't get too hung up on that. And then we're going to go 30 kilometers to the north. Sorry, kilometers per hour. And then we're going to tie back in. So your triangle would look like this. Okay, so we're going to do our Pythagorean theorem. So x equals the square root of 200 squared plus 30 squared. And that is going to give us a value of 202.24 kilometers per hour. So there's half. Okay, so now we're going to find our angle. Okay, so 30 would be our opposite. 200 would be our adjacent. Okay, I'm going to go ahead and skip a step. We know we got to bring that tangent over, so your angle is going to be inverse tangent of opposite, which is 30, over adjacent, which is 200. Okay, and that is going to give us an angle of 8.53 degrees, and it's touching the west line. Okay, so that's your last letter, so it's going to be north of west. Now, it is okay to have a small degree like that because you got to look at your numbers. I went 200 kilometers per hour west and only 30 kilometers north. Okay, so it was a lot more horizontal than it was vertical, so that's why it's a small angle. So your counter angle would be, if you went the other way, you'd have 81.47 degrees west of north. Number 3, a car drives 500 kilometers west and 222 kilometers south. What's the displacement? Okay, so we're going west and south, so west, south. So I'm going to go west first, and I'm going to go 500 kilometers, and then 222 kilometers south. And we're going to tie back in. So our angle is right here, and our hypotenuse is right here. Okay, so now find our hypotenuse. X equals the square root of 500 squared plus 222 squared. And we're going to get a value of 547.07 kilometers. So there is half your answer. Okay, so if I look at my triangle, 500 would be your adjacent. Okay, 200 would be your opposite. Okay, so we're going to go ahead and do inverse tangent of opposite, which is 222, over adjacent, which is 500. And we're going to get an angle of 23.94 degrees. It's touching the west line, so that's got to be my last one, so south of west. And your counter angle would be 66.06 degrees west of south. Okay, number 4, a baseball is accelerating at a rate of 9.8 meters per second downwards. Okay, at the same time accelerating at 5.0 meters per second to the left. Okay, we're going to treat this, our cardinal directions, just treat down like south and left like west. Okay, it's not a big deal here. Okay, so what we're going to do is we're going to go down 9.8 meters per second squared. So again, don't get hung up on the unit. That is just a unit. It's not going to affect anything. And then we're going to go 5.0 meters per second to the left. So we're just going to go left from there, 5.0 meters per second squared. So we're going to tie back to the center. So our angle is here, hypotenuse there. So hypotenuse, square root of 5 squared plus 9.8 squared. And you get a value of 11 meters per second squared. So we're going to find our angle. Okay, 9.8 would be my adjacent. Okay, 5 would be my opposite. So our angle is going to be inverse tangent of 5.0 divided by 9.8. And you will get an angle of 27.03 degrees. Now this is where it kind of gets a little tricky, is it's touching the down line and then going left of it. So that would be technically left of down. And again, we're not going to try to give you much of those. We're just going to stick with cardinal directions. And then if your counter angle, so your counter angle would be right there. So we would also accept 63.97 degrees. Now you could say down of my left line, okay? Or anything that's below the east and west, we'll do more of these. Anything that's below the east and west line, you can just say below the horizontal. So I would accept either one of those. 5, two forces act on an object at the same time. One is a force of 8 N. That just means newtons. Okay, so that's not telling you it's going north. Okay, the unit for force is newtons. So it is going 8 newtons north. And the other force is going 17 newtons east. So again, that's not northeast. That just means we're going 17 newtons east. So I'm going to draw my directions. We're dealing with north and we're dealing with east. So I'm going to go 8 newtons north. So I'm going to go up 8 newtons. And then I'm going to go 17 newtons east. Okay, and then I'm going to tie back to the center. So my triangle will look like this. So my angle is here and hypotenuse is there. So my hypotenuse is the square root of 8 squared plus 17 squared. And you should get a value of 18.79 newtons. Okay, then our angle. Angle is going to be inverse tangent. Okay, so again, if you need help labeling these, okay, 17 would be your opposite. And 8 would be your adjacent. Okay, so inverse tangent of opposite over adjacent, so it'd be 17 over 8. And that will give me an angle of, oops, let me fix that. That'll give me an angle of 64.80 degrees. It's touching the north line and going east of it, so that's going to be east of north. Okay, so the counter angle would be 25.20 degrees north of east. Number 6, if a car drives 3 miles to the north and 4 miles to the west and 5 miles to the north and 6 miles to the west, what's the overall displacement? Now, you can do this whole zigzag thing if you want to. You'd still get a technical triangle right there. But you can just you can save some time and just combine like terms. Okay, so what I would do is, if I went 3 miles north and 5 miles north, just add them up. That means 8 miles north. If I went 4 miles west and 6 miles west, just add them up, 10 miles west. So there's your two directions. So let's draw our directions. So we're going north and west. So I'm going to go north first. So 8 miles north. And I'm going to go 10 miles west. And then I'm going to tie back to the center. So here is your hypotenuse. Here is your angle. So our hypotenuse, x equals the square root of 8 squared plus 10 squared. And you're going to get a value of 12.81 miles. So there's your magnitude. Our angle, so angle is the inverse tangent. Okay, 10 miles would be your opposite, 8 miles would be your adjacent, so opposite over adjacent, so 10 over 8. And you get an angle of 51.34 degrees. It's touching the north line, okay, so that means that's got to be my last letter, so that'd be west of north. And the counter angle for this one would be 38.66 degrees north of west. 7, if a car drives 3 miles north and 4 miles west, 5 miles north and 9 miles east. So there's a reason we bold things like that. Okay, we're going to do the same thing, but we just got to watch out for directions now. 3 miles north and 5 miles north is still 8 miles north. 4 miles west and 9 miles east, you can't just add those together because they're conflicting. So you'd subtract them. So you're going to figure out where would you end up, west or east? Well, you're going to end up east because you had a bigger value going east. And you would say by how much? 9 minus 4 means you ended up 5 miles east. So there's your two directions. Okay, so we're dealing with north, east. So we're going to draw it out, 8 miles north. And then we're going to go 5 miles east from there. And we're going to tie back to the center. So angle goes here. And hypotenuse goes right there. So our hypotenuse is square root of 8 squared plus 5 squared. And that's going to give you a value of 9.43 miles. Okay, so our angle, we're going to do our inverse tangent. Opposite would be 5 over your adjacent, which would be 8. You're going to get an angle of 32.01 degrees. It's touching the north line, okay, and then going east of it, so that's going to be east of north. Okay, your counter angle would be 57.99 degrees north of east. So again, I'm just giving these counter angles just in case you went east first and then north. That would be your answer for your angle. If Dave pushes a cart with a force of 10 newtons to the west and Derek pushes the same cart with a force of 13 newtons to the south, what's the resultant force? So we're going to draw our directions. So we're talking about going west. We're talking about going south. So we're going to go with Dave first. So he goes 10 newtons to the west. Doesn't matter who you chose first. So 10 newtons to the west, and Derek goes 13 newtons to the south. So 13 goes right there, and then tie back in. Angle goes there, hypotenuse. So hypotenuse is a square root of 10 squared plus 13 squared. Okay, and that's going to give me a value of 16.40 newtons. Now we're going to find our angle. So our angle is going to be inverse tangent. Opposite would be 13. Adjacent would be 10. Okay, so we're going to type that in our calculator, and you're going to get an angle of 52.43 degrees. You're touching the west line, so that's got to be your last letter, so south of west. Okay, so it all starts becoming very repetitive. So once you do a few of these, okay, it just becomes the same thing over and over again. So hopefully this homework kind of got that stuck in there. Your counter angle would be 37.57 degrees west of south. Okay, either one of those would be fine. So that would be the end of this video. Now what we're going to do is in the upcoming pages, we're going to learn how to break down the hypotenuse and the angle back into individual components. But that'll be for the next video.